Objectives. At the end of the course, the user will be able to know about Database Management System, that is IDMS, understand the concept of Relational Database Management System terminology, understand the concept of relational model, understand the concept of base tables, know the importance of keys. Introduction to Relational Database Management System. A relational database consists of a collection of tables, each of which is assigned a unique name. The relational model is the most successful model of all the three models designed by E.F. Code. An important feature of relational system is that a single database can be spread across several tables. Data is stored in the form of tables. In tables, data is stored in rows and columns. And IDMS has some properties. It supports null values. It does not hardbind relationship between tables. It does not require the user to know physical implementation of RDBMS. It gives information about the content and structure of tables. Architecture of Relational Database Management System. Relational Database Management Systems support the standard 3-level architecture for databases as shown in figure. Relational databases provide both logical and physical data independence because they separate the external, conceptual and internal levels. Conceptual level. The conceptual level, which corresponds to the logical level for relational databases, consists of base tables that are physically stored. These tables are created by the database administrator using a create table command. A base table can have any number of indexes created by the DBA using the create index command. An index is used to speed up retrieval of records based on the value in one or more columns. An index lists the values that exist in the indexed columns and the location of the records that have those values. Physical level. On the physical level, the base tables are represented along with their indexes in files. The database management system, not the operating system, controls the internal structure of both the data files and the indexes. Once the base tables have been created, the DBA can create views for users using the create view command. A view may be a subset of a single base table, or it may be created by combining base tables. Views are virtual tables not permanently stored but created when the user needs to access them. This is not exactly the same as our term external view, which means the database as it appears to a particular user. In our terminology, an external view may consist of several base tables and/or views. One of the most useful features of a relational database is that it permits dynamic database definition. By contrast, many other systems requires that the entire database structure be defined at creation time and the entire system to be halted and reloaded when any structural changes are made. The flexibility of relational databases encourages users to experiment with various structures and allows the system to be modified to meet their changing needs. This enables the DBA to ensure that the database is a useful model of the enterprise throughout its lifecycle. IDMS terminology. IDMS terminology is used to express and define the special ideas and concepts of the relational database model. 4 categories of terms are described: value-related, structure-related, relationship-related, integrity-related. Value-related terms. Data are the values that are stored in the database. They are static in the sense that they remain in the same state until they are modified. Information is the data that has been processed in a way that makes it meaningful. It can be shown as a result of a query, either displayed on screen or printed on a report. Null is a value that is either missing or unknown. A null value represents neither 0 nor blank, as they are the actual values and can be meaningful in certain circumstances. A drawback of null values is that they cannot be evaluated by mathematical expressions. Structure-related terms. A table is the main structure in a relational database. It is composed of fields and records. It always represents a single, specific subject, which can be an object or an event. A field, that is, attribute, is the smallest structure in a relational database. It represents a characteristic of a subject of the table. A field may be multi-part, multi-valued, or the result of a calculation, that is, concatenated. A record, also known as a tuple, is a structure within a table that represents a unique instance of the subject of the table. A view is a virtual table that is composed of fields of one or more tables. It draws its data from the tables on which it is based. They are commonly implemented as saved queries. Primary key is a field that uniquely identifies a record within a table. Foreign key, which is a field that is used to establish a relationship between a pair of tables. Index is a structure within an IDMS that is used to improve data processing. Relationship-related terms. Relationship establish a connection between a pair of tables. This relationship exists when a pair of tables is connected by a primary and foreign key. Types of relationships. One-to-one exist between a pair of tables if a single record in the first table is related to one and only one record in the second table. One-to-many exist between a pair of tables if a single record in the first table is related to one or more records in the second table, but a single record in the second table can be related to only one record in the first table. This is the most common type of relationship. Many to many exists between a pair of tables if a single record in the first table can be related to one or more records in the second table, and a single record in the second table can be related to one or more records in the first table. Establishing a direct connection between these two tables is difficult because it will produce a large amount of redundant data in one of the tables. Types of participation. There are two types of participation that a table can have within a relationship: mandatory and optional. Each table in a relationship has a degree of participation, which is the minimum and maximum number of records in one table that can be related to a single record in the other table. If records in table A, that is employees, must exist before any records can be entered into table B, that is customer, then table A's participation within the relationship is mandatory. If not, it is considered optional. For example, consider agents and clients table. If we say that an agent should have at least one client but not more than 8, then the degree of participation for the client table is 1,8. Integrity related terms. A field specification, that is domain, represents all the elements of a field. Each field specification has three types of elements: general, physical, logical. A field's general elements include such items as field name, description, and source table. Physical elements include items such as data type, length, and display format. Logical elements describe the values stored in a field, such as required value, range of values, and default values. Data integrity refers to the validity, consistency, and accuracy of the data in a database. The four types of data integrity are table-level integrity, field-level integrity, relationship-level integrity. Business rules. Table-level integrity ensures that the field that identifies each record within the table is unique and is never missing its value. Field-level integrity ensures that the structure of every field is sound, that the values in each field are valid, consistent, and accurate. Relationship-level integrity ensures that the relationship between a pair of tables is sound and that there is synchronization between the two tables whenever data is entered, updated, or deleted. Business rules impose restrictions or limitations on certain aspects of a database based on the ways an organization perceives and uses its data. Referential integrity is a database concept that ensures that relationships between the tables remains consistent. When one table has a foreign key to another table, the concept of referential integrity states that you may not add a record to the table that contains the foreign key unless there is a corresponding record in the linked table. It also includes the techniques known as cascading delete, which ensure that changes made to the linked table are reflected in the primary table. Referential integrity constraint is such as, more generally, Let R1 of R1 and R2 of R2 be relations with primary keys K1 and K2 respectively. R1 and R2 denote the set of attributes of R1 and R2 respectively. We say that a subset alpha of R2 is a foreign key referencing K1 in relation R1 if it is required that for every tuple T2 in R2, there must be a tuple T1 in R1 such that T1 of K1 is equal to T2 of alpha. Requirements of this form are called referential integrity constraints or subset dependent. Relational model. The relational model was proposed by Code in 1970. Diagram of an example database according to the relational model. The model is very easy to understand, although it is based on a solid theoretical foundation that includes predicate calculus and theory of relations. A relation is defined as a set of tuples that have the same attributes. A relational database is a database in which the data is perceived by the user as tables. A tuple usually represents an object and information about that object. Objects are typically physical objects or concepts. A relation is usually described as a table which is organized into rows and columns. All the data referenced by an attribute are in the same domain and conform to the same constraints. Applications access data by specifying queries which use operations such as select to identify tuples, project to identify attributes, join to combine relations. Relations can be modified using the following operators: insert, delete, update. Insert operation, delete operation, update operation. Base tables. The tables which store the data are referred to as base tables. user can directly examine data in the base tables. Base table contains relation, tuple, attribute, field, degree, domain, cardinality, relation. A relation is a pre-defined row or column format for storing information in a relational database. Relation is a two-dimensional table containing a set of relational data created from the entities of the object model. A table is a collection of data elements organized in terms of rows and columns. Example: student table shown. Tuple. Tuples are the rows of the table derived from the entity occurrence of the object model. Example for single tuple or row is shown. Attribute. Attributes are the column of the table usually defined from the attribute of the object model. Example for single attribute or column is shown. Field. Each tuple can be broken into several smaller entities known as fields. The student table shown consists of 4 fields. Degree. Degree refers to the number of attributes in a relation. Shows the degree of a student table and the degree are 4. Domain. Domain refers to the set of allowable values for one or more attributes. Cardinality. Cardinality refers to the number of tuples in a relation. Shows the cardinality of a student table and the cardinality is 4. To keys. Keys are used to establish and identify relation between tables. Keys are very important in relational database. They also ensure each row within a table can be uniquely identified by combination of one or more fields within a table. Types of keys: primary key, foreign key, candidate key, super key, compound key, composite key, secondary key or alternate key. Primary key. Primary key. This constraint defines a column or combination of columns which uniquely identifies each row in a table. Syntax to define a primary key at column level: column name, data type, constraint name, primary key. Syntax to define a primary key at table level: constraint name, primary key, column name 1, column name 2. The syntax within the bracket, that is constraint name, is optional. To create an employee table with primary key constraint, the query would be like, for example, foreign key. Foreign key. This constraint identifies any column referencing the primary key in another table. It establishes a relationship between two columns in the same table or between different tables. For a column to be defined as a foreign key, it should be defined as a primary key in the table which it is referring. One or more columns can be defined as foreign key. Syntax to define a foreign key at column level. Constraint name, references, referenced table name, column name. Syntax to define a foreign key at table level. Constraint name, foreign key, column name, references, referenced table name, column name. Let's use the product table and order items. For example, press F5. Press F5. Press F5. Candidate keys. Candidate keys. A candidate key is a field or combination of fields that can act as a primary key field for the table to uniquely identify each record in that table. Candidate keys are minimal, irreducible superkeys. Superkeys do not have proper subset within the relation. Create table student, student ID number 4, primary key, student name var_char 20 not null, department var_char 20, address var_char 20, candidate key student ID, student name. In the figure, student ID and student name is the candidate key.
Other types of keys. Super key. superkey stands for superset of a key. A superkey is a set of one or more attributes that are taken collectively and can identify all other attributes uniquely. A table can have multiple superkeys, of course, and minimal superkey is considered as a candidate key. Compound key. Compound key is also known as composite key or concatenated key that consists of two or more attributes. A compound key consists of more than one field to uniquely identify a record. A compound key is distinguished from a composite key because each field which makes up the primary key is also a simple key in its own right. Each of the fields that make up the primary key are simple keys because each represents a unique reference when identifying a student in one instance and a module in the other. Composite key. Composite key consists of more than one attribute. Such a multi-attribute key is known as a composite key. Secondary key or alternate key. An attribute or combination of attributes used strictly for data retrieval purposes. A table may have one or more choices for the primary key. One is selected as a primary key. Those not selected are known as secondary keys or alternative keys.
Code's rules. Code provides a set of 12 rules which merits the database product as relational. Of the 12 rules of code for IDMS include Rule 0, that is Foundation Rule. The other 12 code's rules are as follows. Rule 1, Information Rule. Rule 2, Guaranteed Access Rule. Rule 3, Systematic Treatment of Nulls Rule. Rule 4, Active Online Catalog based on the relational model. Rule 5, Comprehensive Data Sub-Language Rule. Rule 6, View Updating Rule. Rule 7, High-Level Insert, Update and Delete. Rule 8, Physical Data Independence. Rule 9, Logical Data Independence. Rule 10, Integrity Independence. Rule 11, Distribution Independence. Rule 12, Non-Subversion Rule. Rule 0, Foundation Rule. A relational database management system must manage the database entirely through its relational capabilities. Rule 1, Information Rule. All information is presented logically by values in tables. Rule 2, Guaranteed Access Rule. Every data value is logically accessible by combination of table name, column name, and primary key value. Advantages of relational model. Simplicity. The main advantage of relational model is the simplicity in representing data than network and hierarchical model. Easy to design, implementation, maintenance, and use. Relational model provides physical, logical, integrity, and distribution data independence, which makes the whole database design cycle easier. It offers flexible and powerful query capability. It is structural independent. Comparison of DBMS and RDBMS. DBMS, RDBMS. DBMS is a generalized software for managing and manipulating the databases. RDBMS is a type of DBMS depends upon the mathematical concepts of relation. DBMS organize data by using data files with records and fields. RDBMS organize data by using tables, tuples, and attributes. Several files cannot be stored in a single file. Several tables can be stored in a single table known as table pools. Physical and logical data independence depends upon the structure of database. It provides physical and logical data independence by using mappings. Data handling, transaction processing, and other features are less powerful than RDBMS. RDBMS have more powerful data handling, transaction processing, and other features to enhance speed, security, and reliability. Summary. In this class, we have learnt about basics of data and information and its difference, concept of Relational Database Management System, that is RDBMS, concept of Relational Database Management System terminology, basic knowledge of relational model, basic knowledge of base tables and keys.